this video we are going to learn about model summaries to inspect the model more closely, to take a look at the number of parameters and the expected input and output sizes. So another thing I like to do is to print a model summary to get a better idea of the architecture of the model to make sure it looks like as we intend it to look like. So the code here is similar to the code that we used previously in Unit 6. So we have our PyTorch multilayer perceptron, the lightning model, and then the trainer here for training down there. So I will make a small modification now to the lightning model. And in particular, I'm going to add something called example input array. So now I'm adding an additional line of code here to my lightning model. This is the example input array. So this is a special attribute, example input array, and you will see in a moment what it's used for. How we define it is, we just assign a batch here. It can be just an empty tensor. The only thing that matters is that we get the shape dimensions right. So since our network works with 100 features down here, we have to provide 100 features here, and 5 is the batch size. So we have batch size 500 features. Now this is a special attribute, as I mentioned, and this allows us to add a model summary now. So what I can do now, I can add a summary here. So for example, I can say from Lightning PyTorch utilities model summary import model summary, and then I can define the model summary. So this would be our lightning model. And then we can also define the depth, how detailed the model summary is. I like to use -1 here to get a complete summary. And then we print the summary. So let's execute the code above to take a look at how that looks like. So now we can see the model summary here. Notice that the input size is 5 × 100 because that's what we defined up here for our example input array. But now we get an idea of what the model, the PyTorch multilayer perceptron looks like. So we have our sequential layer here, which takes in 5 × 100 and outputs 5 × 2. So the batch size here is conserved, but it goes from 100 features to 2 output classes essentially. And now here is a more detailed look into the sequential class. So here we have a bunch of layers, a linear layer, batch norm, relu, linear, batch norm, relu, linear. So linear, the last one would be the output layer, and this would be the first layer, and this is the second hidden layer. And in between we have then of course batch norm and relu. What's nice is that we can also see the number of parameters here, which can be sometimes useful when we want to compute the total number of parameters. So here the total number of parameters is 15.6. And the estimated model size is 0.062 megabytes, which is tiny. Later in this class, we will be working with quite large models. So this is a very small model. Enjoy it while it lasts. So in this notebook, I showed you how to use a model summary, which is sometimes very useful when we are working with new architectures. So in this video we learned about the model summary class, which visualizes the number of parameters of the model as well as the expected input and output sizes, which can be sometimes very useful for debugging purposes. Now if we inspect such a model summary and don't find any obvious issues here, it still doesn't mean that there are no other issues somewhere else in the code. And in the next video we will learn about a trick that we can use to inspect whether the model is training or not. Now if we find that our model looks correct, but there are still some training issues, in the next video we will learn about another technique that we can use for debugging.